This type of question is very important. Then you have to find the hybridization of the molecule, or how many lone pair or bond pair present in the molecule, what is the shape of the molecule. So to find this type of answer, we have to use this formula, H equals to half V plus M minus C plus A. Now what is H? H is the number of hybrid orbital. What is V? V is the number of valence electron present in the central atom. M is the number of monovalent atom, that is monovalent means hydrogen, chlorine, fluorine, bromine, iodine, sodium, potassium, this type of atom we have to count. There is a monovalent atom. Next, C is the charge on cation, A is the charge on anion. Now we have to find the value of H. Now if the value of H is equals to 2, then it will be sp. One s and one p, they will form two orbitals, that is sp orbitals. 1s and 2p, they are combining together and form three orbitals. That's why H equals to 3. And if the value of H equals to 4, that means 1s and 3p. Next, H equals to 5, 1s, 3p and 1d, that is sp3d. H equals to 6 means sp3d2, that is 1s, 3p and 2d. And H equals to 7 means 1s, 3p and 3d, so sp3d3. So with the help of this H, we can easily find the value of the hybridization. What is the hybridization? Now if we know the hybridization, we can easily find the shape of the molecule and the number of lone pair and bond pair present in the molecule. If we are finding the hybridization of any molecule, then we can remove the C and A from the formula, and we have to write only H equals to half V plus M. Now by using this formula, we will find the hybridization, the shape and number of lone pair and bond pair present in the following molecules. The molecules are, first we will take methane. So first we have to calculate the value of H, that is half. Now what is the electronic configuration of carbon? We can use 1s2, 2s2, 2p2, or we can use simply 2, 4. Then we have to calculate the number of valence electron present in the molecule, that is 4, and the number of monovalent atom, that is also 4. So H will be 4. Now if the value of H equals to 4, that means it is sp3 hybridized, and if it is sp3, then the structure will be, the shape of the molecule will be tetrahedral if all the hybrid orbital are used to make the bond with the atoms. So there are total 4 hydrogen atom, and these 4 hybrid orbital will make the bond with the hydrogen atoms. We will continue with the second one, that is ammonia. So for ammonia, what is the value of H? H will be half. Then the electronic configuration is 2, 5 for nitrogen, so valence electron is 5. Number of monovalent atom, that is 3, so value of the H will be 4. If it is 4, that means sp3, so the shape will be 1, 2, 3, 4, that is a tetrahedral shape, but we have only 3 hydrogen atom, so 3 hybrid orbital will make this bond, but 1 hybrid orbital, that is vacant, that means there is a lone pair. So there are 3 bond pair and 1 lone pair. Now we will continue with the third one, that is water molecule. Number 3 is water molecule. Here oxygen is the central atom, then H will be equals to half V. V means the valence electron 2,6, so 6 is the valence electron of oxygen. There are 2 monovalent atoms, so H will be 4. Now what will be the shape? Total 4 hybrid orbital, but here only 2 hydrogen will make a bond with oxygen atom. That means there are 2 lone pair. There are 2 lone pair. So we can easily predict the shape of this molecule, that is a V-shaped, and for the ammonia it will be a tetrahedral shape. Is a pyramidal shape. Is a pyramidal, because we are not counting this lone pair when we are making the shape. So if NH3 having 1 lone pair and 3 bond pair, so we will take only this part. So this is a pyramid. It's a pyramidal shape, and for water molecule is a V-shaped. For the methane molecule it was a tetrahedral shaped molecule. So we will continue with the next one, number 4, that is BEF2. So BEF2. Now what is the value of H? That is half. Number of monovalent atom is 2, and what is the valence electron of beryllium? The configuration will be 2,2. So valence electron is 2, monovalent 2, so the value of H will be 2, and 2 means SP. The shape will be BEF2. There are 2 atoms, so it will be a linear shape. So you have to learn the shape. Say for H equals to 2, the shape will be linear. So there is a central atom connected with the 2 atom. Maybe these atoms are monovalent or bivalent, so we can use this structure for H equals to 2. For H equals to 3 we are using this shape. So if there are 3 atoms, so the central atom will connected with the 3 atoms. If there are only 2 atoms, then 2 will be connected with the central atom and 1 will be the lone pair. Say H equals to 4, then it will be tetrahedral shaped, that we have already learned. If H equals to 5, then it will be a trigonal bipyramidal shaped. So this is a triangle, this is a triangle. There's a this position is known as equatorial position, and these two are called the axial position. Okay, so this is called the trigonal bipyramidal. Why? This triangle, and if we join this we will get a pyramid. And for the second one we will get the 2 pyramid for this structure. So it is called the trigonal bipyramidal, as the base is a triangle. Okay, so this is for 5. For 6, H equals to 6, we have a central atom connected with the 4 atom to make a base. This is a square base, and there are 2 more atoms. It is called the square bipyramidal because it's forming a pyramid. So it's a square bipyramidal structure. And for H equals to 7, there's a pentagon. So H equals to 7, there's a pentagon. So the central atom connected with the 7 atoms. So 5 atoms are combining with the central atom to form the base, is a pentagon base. So connected with the 2 atoms. These are when these 2 positions are forming in any H equals to 5 or H equals to 3, H equals to 5 and H equals to 7. These two positions are called axial, so it will be applicable only for H equals to 7 and H equals to 5. These positions are called as axial position, and these 5 are called the equatorial position. Next we will start the fifth one, the fifth structure, that is BF3. So first we will find the value of H, the valence electron 2, 3, the atomic number of boron is 5, so the valence electron is 3. Now how many monovalent atoms present here? 3. So the value of H will be 3. Now if it is 3, then we are connecting the 3F atom with the boron, and it will make a trigonal planar structure. The shape is trigonal planar and the hybridization is a sp2. This sp2, 3 means H equals to 3 means sp2. So the shape, the hybridization and the number of lone pair or bond pair electrons we can easily find with this formula. Next will be number 6. So PCl5. So H equals to half. So what is the electronic configuration of phosphorus? Is 2,8,5. So 5 will be the valence electron, the monovalent atom here 5, so H will be equals to 5, and then the shape will be phosphorus. It will form the trigonal bipyramidal shape because all the 5 atoms are present here, so it will form a trigonal bipyramidal shape. Here these 3 are called the equatorial position, these 2 position is called the axial position. Okay. Next we will find the hybridization of ClF3. Here H equals to half, the valence electron of chlorine will be 7 plus number of monovalent, that is 3, so H will be equals to 5. Now if it is 5, we have 2 special structures, that is H equals to 5 TBP, trigonal bipyramidal, and second one H equals to 7, that is pentagonal bipyramidal. For this 2 structure, that is sp3d and sp3d3, for these 2 structure we have to use a specific rule called Bend's rule. This rule says that the electronegative element always occupy the axial position. Now if we are placing the fluorine in the axial position, then the third one will occupy any one place of this equatorial position. So we are placing F here, and these 2 positions are having lone pair. Why this is applicable only for H equals to 5 and 7? Because for these 2 structures, say if we are consider the equatorial and axial position, all the bond formed by the central atom present in the equatorial position, their angle will be 122 degree, but the bond with this axial position is 90 degree. So the bonds are different. So when the electrons are present in this bond, they will repel each other. That is called the valential electron pair repulsion. This theory is called valential electron pair repulsion theory, and this electron will repel each other. So we have to follow the Bend's rule. Bend's rule says the equatorial position, the axial positions first occupied by the electronegative elements. That is called the Bent's rule. Now if we are draw the next one, so what will be the shape of the molecule? This is a T-shaped, because we are not considering the lone pair, so the shape is looking like this. So this is a T-shaped. Okay, so our next one is PCl3F2. PCl3F2. So the valence electron in the central atom is 2, 8, 5. So H will be equals to half, that is 5, plus total number of monovalent atom is 5. So H will be 5. Now it is also sp3d. Now P at the middle. First, according to Bent's rule, the axial position will be occupied by the electronegative elements. So here fluorine is the most electronegative element, so it will first occupy the axial position, and then the rest position will be occupied by chlorine. But if we are not considering the Bent's rule, then the shape, not the shape, the position may differ. Say first we are putting Cl here in these two position, so that will be wrong. So we have to follow the Bent's rule, and this rule says that the axial position always occupied by the electronegative elements. Okay, the next one, number 8, is SF4. So H will be equals to half the valence electron 2, 8, 6. So it is 6 plus number of monovalent atom, that is 4. So H equals to 5. H equals to 5 means S, then 5 position, but here we have only 4 atoms. So the 4 atoms, that means the first 2 fluorine will be occupied by these 2 fluorine first occupy the axial positions according to Bent's rule. So we can place another fluorine here, and this position having the lone pair, and this structure is called the seesaw shape. Is a seesaw shape, and the hybridization is sp3d, and we have 4 bond pair, 1 lone pair. Okay, continue with the next one, number 9. So we have carbon dioxide. So the electronic configuration 2, 4, H equals to half, 4 plus, there is no monovalent atom, so monovalent atom is 0, because oxygen is a bivalent atom, so we can't take oxygen. So H will be equals to 2, so it will be sp means the linear structure, so we have to put 2 oxygen here, but oxygen is a bivalent, so it will form 2 bond with the oxygen atom. Next, number 10 is XeOF4. So xenon, it has how many valence electron? 8, because all the inert gases, all the noble gases having the 8 electron in their valence shell. So H will be equals to 8 plus number of monovalent atom here 4, we are not counting oxygen, so it will be 6. So Xe 1, 2, 3, 4, 5, 6. This 4 first we are filling with fluorine. There's 1 oxygen and 1 vacant place, that means 1 lone pair, and oxygen is a bivalent atom, so it will form a double bond. So if we are joining this, all this fluorine, we'll get a square base, and then it will forming a pyramid with oxygen atom. So it's a square pyramidal structure having 1 2 3 4 5 bond pair and 1 lone pair. Next, and what is the hybridization of the molecule? Is sp3d2. Is sp3d2. Next we have XCF2. Next one is XCF2. So Xe have 8 electrons, their valence electron is 8, so the formula will be H equals to valence electron 8 plus number of monovalent 2, so H will be equals to 5, so Xe 5, 1 2 3 4 5. There are 2 electronegative element. First 2 will connect with the xenon in their axial position, and then 3 vacant place, that means 3 lone pair. So what will be the shape of the molecule? Is a linear molecule. Is a linear. Xc is a linear molecule like this. And what is the hybridization? That is sp3d. This is the XCF2. To find the hybridization and the shape of the ions, we are using H equals to half V plus M minus C or plus A. If it is cation, then we are using the charge of cation here. If it is anion, then charge for anion for A. Say we have say first one ClO3 minus chlorate ion. So for this one the same thing, you have to calculate the valence electron for the central atom. So it is 287, so H will be equals to half, that is 7. There is no monovalent atom, and the charge is -1, so you have to add this charge. If it is minus, we have to write it as plus. If it is plus, then we have to write it as minus. So the value of H equals to 4. Cl 1 2 3 4, that is tetrahedral, but there is only 3 atom, so 1 will be lone pair. So 3 atom we have to add with chlorine. There are total 3 oxygen, but there is only 1 negative charge, so only 1 oxygen will carry this negative charge. That means it will form only 1 bond and having with minus charge. But if it is neutral, then it will form 2 bond with this chlorine atom. So what will be the hybridization of this molecule, of this ion? It is sp3. And what is the shape of the ion? It is that pyramidal shape, because we are not counting the lone pair. Now in this ion, chlorine is neutral, but this oxygen atom having this negative charge, so we are writing the formula ClO3 minus, this minus for the oxygen atom. Next, number 2, NH4 plus, H equals to half. The valence electron in nitrogen is 5. The number of monovalent atom, it is 4, and there's a negative, there's a plus charge, that means -1. There's only 1 charge, +1. So for cation we are subtracting that charge, so the value will be 4. So it is sp3. So nitrogen having 4 place is connected with hydrogen, and that positive charge is carrying by nitrogen atom. So with this help of this formula, we can easily calculate the number of lone pair, number of bond pair in the molecule or ions. We can predict the shape of the molecule. We can easily find the hybridization